Hey YouTube fam, welcome back to another episode on Code with Annie. Thank you so much for all the support you have been giving me so far. I'll continue to put more videos in this playlist of fundamentals with Java, and feel free to hit the comment section and let me know what other topics in Java you want me to cover, and I will be happy to put a video on that too. So without further ado, let's delve into this video, which is going to talk about generics in Java. So what are generics? Generics are basically data types that will ensure that there is a compatibility across different data types through a single implementation. What I mean to say is, let me give you an example and show you. Let me create a class called generic sample. Okay. Now what I'll do here is, this is a normal class. I'm just going to annotate this class or append this class with a type parameter called type T. So this is how you add a generic representation. You put an angular bracket open, type T, angular bracket close. And within this is going to be my data type that this class will operate on. So I'll say private T value. Okay. I'll have a constructor public generic sample, and I'll say T space value. And what I'll do is I'll assign this dot T, this dot value is equal to value. Okay. Then I will have a getter method public T get value. Okay. And I'll return value. So this is a very basic representation of how a generic class will look like. The reason is this type T can be replaced by any of the data types available in Java. It can be integer, string, boolean, float, double, or any custom data type like employee age that we created, right? It's a Pojo class we created. Even this can go in as a parameter to generic sample in type T. So this brings us to an important question, like why generics is used in the first place when you have individual data types, right? Generics is used because you want to reduce the boilerplate implementation of certain logic which can be common across multiple data types. For example, let's take the example of collections per se. Collections will be a new video down the line, but I'll explain what collections are. So those are nothing but the list, map, set, queue, stack, all these data types which have a set of data bound inside them, right? So they will have certain properties like adding a new element to a list. Now that element can be a string, integer, boolean, double, float. It can be any of these data types, right? So add operation is going to be common across all of these data types in the collection, right? So that's why collections will make use of something called as generics, because they don't care what data type comes in here, but they will perform the add operation irrespective of the data type. Okay. So that's the reason why generics is in place in Java, and it's a very powerful tool even that can be used when you write your own logic in your real world programs, right? If you want to extend this particular use case, let's say there's an integer use case that you have and you want to extend that to string or double or float, you can simply create a generic and probably apply the common logic inside the generic class. It's a very powerful tool, and that's the reason why it's one of the more important concepts in Java. Let's see how we can instantiate this generic sample. Now what I'll do is I'll create an object for it, generic sample. Now as soon as I write generic sample, I'm expected to pass in the data type that will be replacing T. Let's say I start off with integer, okay, space generic sample, or I'll say integer generic sample is equal to new generic sample of 10. Okay, as soon as I define my class instance, I need to set the value for T, because JVM at compile time when it tries to convert this to bytecode will automatically replace this particular T with integer when it sees this line. So it has to know when it compiles it to bytecode, what is going to be my type T that is going to get replaced with, whether it's integer or boolean or string or whatever it is. Likewise, I can also say generic sample of string space string generic sample equal to new generic sample of, here I can pass in a string value. I can say hello. Okay. Now, when I say integer generic sample dot get value, it is going to return 10, and if I do control D, it basically copies the line I just have to replace this with string generic sample. These are some shortcuts in keyboard that you know. If you know, it is well and good. If you don't, it's just Control D and it'll just duplicate. Control Z will just undo it. Okay. Now system.out.println string generic sample dot get value is going to return hello. And one other interesting thing I'll show you is integer generic sample. If I try to assign it to generic sample, string generic sample, it'll throw an error saying these are two different data types on which they're operating. Even though generic sample of T accepts a type T, right? The type T will change because one is integer, one is string, and they are not inter-assignable. So this ensures there is type safety when you're trying to write a generic code. Okay, keep this in mind. Writing generics and defining generics will ensure there is a type safety in your code. Now let's run this quickly, and we should see the expected outcome. Yep, and here we have 10 and hello. Okay, although the operating method for both of these is same, get value, the value that these two return is completely dependent on what type of data I set for them, whether it's integer or it's string. Now I have set it string, right? Now what if I try to give an integer here? Let's see. It will immediately throw an error saying that I expected a type string, but you have set an integer. So once I define that this is going to be a string in the angular brackets, I need to pass the constructor with a string value. So this is the power of generics, and this is the purpose of why generics is introduced in Java. And I hope you like this video. If you liked it, do hit the like button. Subscribe to Code with Annie if you haven't already. And I'll see you guys in the next video. Bye bye.